Okay, if you're watching this video, it means that you have already finished the Mastery Practice 2 and you have no issues with that question. So let's begin with let's try 3. So all you have to do in this video is just to watch along for the moment and just follow along with my working. If you need to at any point, you can always rewind, pause, or if you think it's too easy, you can fast forward to the next part. Alright, so let's look at this question. Let's try 3. In the diagram, you have AB is 7.5, AB is 4.5, BC is 8, and then angle ABD is 90 degrees, angle CBD is 110 degrees. Now, this question is not as simple as the previous questions because here we have two triangles. So there is a bit of a decision making that you need to make. For instance, let's look at part A where you have to calculate BD. So where is BD? BD is this line over here. And to think about how we're going to calculate BD, we may need to consider which triangle we want to choose. Is it ABD or is it BCD? The first question you need to ask yourself is it right angle triangle? Because only with a right angle triangle can we consider things like Pythagoras theorem or Picasso. Remember this, if it is not right angle, we cannot use any of these properties. Alright, so let's look at triangle BCD. Is it right angle? So far we only know that there is 110 degrees here, and it is unlikely that these two are going to be right angles. Therefore, we cannot use triangle BCD. We need to consider triangle ABD. Alright, so let's look at triangle ABD. We want to find BD. We have this length and this length, so we want to find the last length. We're going to use Pythagoras theorem. Alright, so by Pythagoras theorem, you have AB squared plus BD squared equals to, the hypotenuse is AD squared. So let's write that down. AB is 4.5 squared plus BD squared equals to 7.5 squared. BD is equals to, bring over the 4.5 squared and take the square root off. So let's do that step by step. BD squared is 7.5 squared minus 4.5 squared. That gives you 36. So BD is equals to 6 cm. Okay, so let's label that since we have found that. So BD is 6. Now if you want to find the area of triangle BCD, well, that's not too difficult, right? Because we've already found 6 here, and we have 8, and this gives us the angle in between. So just using our formula, area of triangle BCD equals to half AB sine theta, or AB sine C. So half times 8 times 6 sine 110 degrees. Press your calculator, you will get 22.6. Do not forget your units, and do not forget rounding off to 3 SF. Okay, so let's move on to question 4 now. In this case, you are given a parallelogram, and we have seen how to find area of parallelogram only just in the previous few questions. Alright, so let's look at this one here. Part A, find the area of the parallelogram. Well, we are able to cut SQ in draw the diagonal SQ so that we can cut the parallelogram into two triangles here. We know that because it is a parallelogram, this has to be 8 and this has to be 10. So let's first find the area. We know that there are two triangles, so area of PQRS, well, it is 2 times of the area of the triangles, right? So 2 times half AB sine C, so half times 8 times 10 sine 67 degrees. Press your calculator. Alright, 3SF, you will get 73.6 centimeter squared. 3SF. Let's look at part B now. Find the perpendicular distance from Q to PS. Okay, the keyword here is perpendicular distance from Q to PS. So let's draw an additional line. Well, we're going to start off at Q. So it has to start from here. And it has to go down to PS somewhere in between, such that I get a 90 degrees, right? Because they are telling us that it is a perpendicular distance. Okay, perpendicular distance. So that's where we produce this 90 degrees. Okay, if that's the case, then, well, let's call this point X. Okay, and we see that there is a right angle here, PXQ, right? PXQ. This is a right angle. We know 10. We know the angle is 67, and will bring us to find QX, right? So here 10 is the hypotenuse, PX is the adjacent, and QX is opposite. So we want to find this. We have this. We are thinking of opposite and hypotenuse that's related to sine. So in part B, sine 67 degrees is equals to QX over 10. And we're looking for QX. So that's just 10 sine 67 degrees. Press your calculator, you will get 9.21 meters 3SF. Alright, sorry, centimeters. Okay, so once you're done with this, go over to the next page. Try the question yourself first. So press pause. Once you're ready, then press play to watch the solution. Okay, so I'm gonna do the solution for Mastery Practice 5. Let's look at this question now. They've given us some lengths. AB is 3 cm, AD is 2x, BAD is 74, and the area is now 100. So they've labeled all this down for us, and we need to find the value of x. Well, let's recall our formula for the area of parallelogram. Again, if we cut this into two, we get two triangles. So the area of ABCD is just equals to 2 times of half AB sine C. I'm not going to do a substitution yet. Okay, so, and we know that this is equals to 100 centimeters square. So let's put this all together. 2 times half AB, so 2x times 3x sine, the angle has to be in between the two lengths. Okay, sine 74 degrees is equals to 100, right? So now all we have to do is simplify and make x the subject. So let's work on the left side first. 2 times half, well, that gives us 1. 2x times 3x, this is 6x squared sine 74 degrees equals to 100. Make x squared the subject first, so divide by 6 sine 74. So 100 over 6 sine 74 degrees. And if you want to find x, well, we need to take the square root of this value here. Obviously, it has to be the positive value because we're looking for lengths. So the square root of this gives us 4.16 centimeters, rounded off to 3SF. Okay, once you're done with this video, then move on to the think question. And if you're done with that, if you got something written down for that, let me know. And once you're done with that, you can also move on to start on your homework questions. Alright, so that's all for this video. Thank you.